You don't understand what is critical angle.
It is really difficult.
Yeah, look here. We have the ray is going from denser to rarer medium, right?
Yes, sir.
So if light goes from denser to rarer medium, then light bends away from the normal, right? Isn't it?
Yes, sir.
So it is going if we are drawing angle, uh, drawing rays. Uh, for example, this is one of the rays. Okay, like this one, less than critical angle. I am drawing one here. Then we have light rays bending away from the normal. Away from the normal, how you understand the angle of refraction will be greater, right?
Yes, sir.
Here, angle of refraction is greater, right?
Sir.
Yes, yes. Just a minute. Just a minute. Excuse me. Okay, yes. Karim.
Yes, sir.
So if we increase this angle, the angle of incidence, the light ray will bend little bit more, right? It will go down. This
Yes, sir.
refracted ray. And at one stage, what will happen? Light ray will go straight with the surface, right? Isn't it?
Yes, sir.
That
Yes,
means
sir. I got it.
refracted ray will make 90-degree with the normal. Is it clear?
Yes, sir.
So at that point, our incident angle of incidence, that one we are getting, that is called critical angle. So what Amjit said is clear to you, right?
Yes, sir.
So he said that angle of incidence for which the angle of refraction is 90-degree, that is called critical angle. It's clear, right?
Yes, sir.
So the condition for critical angle, it should go from denser to rarer medium. If it goes from rarer to denser, you will never get critical angle. Is it clear? Hello?
Yes,
Is it
sir.
clear? Then
Yes, sir.
we have another formula, the fourth formula for calculating the refractive index, that is n equals 1 by sine c. Okay? C is here critical angle. If you know the value of critical angle, then you can calculate refractive index.
What if we don't have?
Hmm? Sorry?
What if we don't have the critical angle?
If you don't have critical angle, then you will be given angle of incidence, angle of refraction. From there you can find. Okay?
Sir, can we also find it with the help of refractive index?
You are going to find refractive index. So uh, if you already have refractive index, that what we are going to find? You are
No,
asked to find
we have,
refractive index. Uh,
no, sir. We have the refractive index
then you can find critical angle.
by putting the
That
value
formula, yeah.
sine
See,
and manipulate the formula and makes add the
yes.
subject like that.
In many ways you can do. You will see them in the worksheet. Okay. Uh, If you know this formula, four formula, you can solve them. And you did many questions you did in class 9, right?
Yes, sir. He did.
Okay, now you have total internal reflection. You see what is total internal reflection? Tamjid, Tamjid,
Yes, sir.
what is total internal reflection?
It is when light travels from a denser medium to rarer medium, the angle of incidence gets totally reflected since it is greater than critical angle, uh, and it stays inside the medium, the reflected ray.
Yeah. So
Refracted ray.
uh, you see here, Karim, angle of
Yes, sir.
incidence is greater than critical angle, right?
Yes.
Yes.
When it is critical angle, then light rays are going through this surface, right? The
Hmm.
Yes,
medium
sir.
surface between these two medium, there is surface that one is going. But if it is greater than critical angle, then light will no more refract. It will return back to the same medium, isn't it?
Yes, sir.
Hello, and this process is called total internal reflection. Is it clear?
It is like when the when the angle of incidence is greater than the angle of critical value, then the ray of light, without going to the surrounding, it just reflects inside
Yeah, reflects back to
the.
the same medium. Yeah, return back to the same medium. This is called total internal reflection. It's not like the normal reflection. In normal reflection, we are using opaque object, right?
Yes, sir. No, where it will
Yeah,
just hit and
but
have
yeah,
no place
but
to
here
refract.
we are having transparent where light supposed to refract, but because of the angle, it's now reflecting back. That's why it is called total internal reflection. Is it clear?
Yes, sir.
Yes,
Hello.
sir.
So now we have here prism, huh? Prism and
Hmm.
periscope. The application of total internal reflection we have. You see, one thing we have to understand from here, that is here light rays. Yeah, Tamjid, you also listen, huh? Tamjid,
Yes, sir. হ্যাঁ,
yeah,
শুনতেছি।
light rays is going to the glass block, and the angle here, the light has, that is 0 degree, right? With the normal, isn't it?
হুম.
When
Yes,
light
sir.
enters here into this prism, that time the angle is 0 degree because it's going along the normal, isn't it? So if it is
Yes, sir.
going along the normal, that time it's not bending. Though it's going from one medium to another medium, though its speed is decreasing, but it's it's not bending. This one you have to remember. Okay, is it clear?
Yes, sir.
Okay, so here we are having total internal reflection because the angle of incidence is greater than critical angle, and it's going to other prism. Same way it's returning back to the eye. Okay, and you can use this periscope to see the far far objects. You see what is the use of periscope? It is a submarine to see above the sea surface, to see over the heads of people in a crowd. With the mirror also you can make periscope. Okay, here we are using uh,
Uh,
transparent
Placing the
objects.
45-degree angle in a cardboard box like that.
Yeah, yeah. So it's simple thing, right? Periscope, you know, and these are the applications of total internal reflection. We are using in periscope, binoculars, then optical fibers. So Tamjid has one question about
Okay, how are the
optical
total internal?
fibers. Yes,
So what if we use means normal mirror as to make periscope? Will that be also an total internal, or it would be just
that is
normal
only
reflection?
reflection. That is only reflection. But here we are getting
But
total internal
mirror,
reflection.
on that time it becomes total internal reflection.
Yeah, here we are getting total internal reflection, but with mirror we are getting only reflection. Clear?
Yes, sir.
Okay, optical fibers. Yeah, Amjit, what you did not understand in optical fiber?
স্যার মানে the refractive index,
Mm-hmm.
হ্যাঁ রিফ্র্যাক্টিভ ইন্ডেক্সটা কিভাবে মানে উপরেরটা আহ,
Okay, okay, okay. This one you are
কম
talking, right? This one. Is it? Are you talking about this one?
yes yes about
Okay.
মানে
Yeah. Look here, we have uh, two parts, right? One is cladding, another one is narrow core, right? So it's written here, you see, the core is covered by a second layer cladding also made from high purity glass.
So what is high
You
purity
see,
glass?
high purity means there is no contamination. It's only glass. Like the glass we are using, maybe there are some other things mixed. Contamination is there. But this one is
Like
completely,
gorilla glass in which there are potassium atom
yeah,
molecules that it
many
makes the
many things might
core.
be there. Like we have distilled water and normal water, like that, isn't it? So we have here pure glass, like that. Distilled water and the water we are drinking are not same thing, right? The tap water and distilled water are not same. Otherwise, we will do everything in experiments in chemistry lab with normal water. We are not doing that. We are using the distilled water. So
Is there any reason for using the high purity glass, which
yeah, if you have high purity glass, then you can do your work better, right? The
okay, sir, that
density,
means we're
it will
gonna
be
see it.
uniform everywhere. The density of the glass will be uniform everywhere. So here we have the
Now I get it.
core. Yeah, the core we have high density, right? uh, Thin core of high purity glass. The core is covered the second layer of made purity glass. The cladding is less dense. That means outer layer is less dense. Are you understanding, Amjad? The outer
Sir,
layer,
if
that is cladding, this
added
part, this shaded part, bluish shaded part, this is less dense. And here in the middle, the reddish part, yellowish part, reddish part, or whatever you say, that part is more dense. That is narrow core. Is it clear?
should I write beside them? Then it would be easier to understand.
No, it's written. You just remember the inside one is more dense and the outer one is less dense because it is the condition for total internal reflection. It should go from more dense to less dense, right? Isn't it? So it's simply you will understand the light ray how it is going. This one is more dense and the other one is less dense. So it's clear. This clear
Yes,
is
sir.
clear. Kamjit, hello, hello, Tamjit,
yes sir
Tamjit. Are you clear now?
হ্যাঁ স্যার, হ্যাঁ হ্যাঁ।
The inner one is more dense, the outer one is less dense. Both the outer layer, this one and this one, both are cladding.
What was the reason for that?
Yeah, this is for simply we are saying it's if it is
Is
not, you see, if it is not
like the
less
problem
denser
that
and
you
if
are
it is not more denser, then there will be no in total internal reflection.
means because this is less denser, it needs like more. If it is more towards the normal only, then it can like reflect.
Yeah,
Is this the reason for?
you can have then critical angle. You can have then more than critical angle if light is traveling from more denser to less denser. And we made this arrangement here for that reason so that there can be total internal reflection. We are giving the first ray with more than critical angle, then it's continuous. This way, total internal reflection. Is it clear?
Yes, sir.
So these are the things we have got in this topic about uh, till the total
That
internal reflection. Then we have lens. In lens, we have ray diagrams, very important. So uh, we have mainly in our O level, we have mainly converging lens discussion, diverging lens little bit. So we are learning some of the terms here. You see this one, this horizontal line is principal axis. Okay, and the parallel rays with this principal axis going through the converging lens, they are converged converge at a single point on the principal axis, that is called focal point or principal focus. Is it clear? Hello.
Yes sir.
And from here in the middle of the lens where it is called optical center to the principal focus, this distance is called focal length. Okay, Karim, you understand what I'm saying?
yes, sir.
Focal length. And this line, these dotted lines, you can see one dotted lines, right?
Is this normal?
Yeah, this one, the vertical one. You can see the dotted lines. What is the name of this line? Can anyone say?
Sir, normal.
Yeah. Did you know what is this?
কোনটা স্যার?
This vertical line. We have dotted lines. What is
It's
that?
the optical axis.
Yes, optical axis. Have you labeled it?
Yes.
Yeah, this one you label as optical axis. So we have here optical axis, principal axis, optical center, focal point, then focal length. These are very important things you have to remember and to draw the ray diagrams. So now we are having rules for drawing ray diagrams. Look, here is the object and we have focal point here, focal point and double of the focal point also we labeled. So from the optical center to F we have focal length, then optical center to 12, that means double of the focal length. Now our object is outside the double of the focal length, that means the rays are coming from a far distance, right? Hello. Hello.
Section
Uh,
basic.
If the light rays are outside of 2F, then we consider that light rays are coming from far distance.
Hmm.
Is it clear?
Hmm.
Hello?
Yes, sir. Has
And
Santoshi.
it is
yes, sir.
happening. Hello, Karim?
Has sir.
Sir.
Karim,
Yes, sir.
you understood it?
No, sir.
Yeah, if light rays are coming from outside the 2F, then we consider it's coming from far distance. Like you are seeing one aeroplane in the sky. That is far distance, right?
Yes, sir.
And when you see the aeroplane, it is very small, isn't it? A bird you see, very small, isn't it?
Yes, sir. And it gets easy to paint when it is small.
Yeah, but if you see it in front, it is very big, right?
Yes, sir. Thousand
When you
times
are
than me.
traveling with aeroplane, it's so big, right? But this flying in the sky is very small. So why it is? Because our lens is converging it, and the rays are coming from far away. Then the image size you see is coming smaller, isn't it? Hello.
Yes,
So you see the object size is bigger, the image size is smaller. Is it clear to you?
Yes, sir.
yes, sir.
So we have here the object not that far, a little bit far from the lens, but if this object is a bit more far, then the image size will be more and more smaller. So this one we are getting in our camera or eye, a human eye, the formation of image is like that. It's outside the you see camera or human eye, we are having the object outside of 2F, then these rays are coming. You see the first ray, you see first ray, this is the position of lens, right? Optical axis, this double headed arrow is showing you the optical axis. Okay, so when light goes parallel with the principal axis, it's bending, it's going through the focal point. Yeah, Karim, Amjad,
Yes, sir.
yeah, you if you understand it, then you can do any sort of ray diagrams. Be
Hmm.
very careful, both of you. See, the
Hmm.
parallel ray is coming from the object. Parallel means parallel to
Aim
the
of the parallel ray going with the object,
yeah
means with the principal axis.
principal. It is principal axis, right? So parallel means
And
parallel with the
going
principal
straight to it.
axis. It's going through the focal point. Okay, is it clear?
Hmm. Yes.
Then the other ray, second ray, is going through the optical center. It's going without bending. If light rays are going through the optical center, it will not bend. Is it clear?
Yes, sir.
It will go straight. Then
Hmm.
the first ray you got, just opposite of first ray we are getting. Look here, the first ray was this side we are getting parallel. Yes, Karim, you have any microphone problem?
Sir, I don't know.
Okay. So what is the
Yes,
ray? We are getting lots of rays from the object, right? So we are only showing few rays, these three rays, the first ray, second ray, third ray. Okay. Hello,
yes, sir.
Karim. So
Yes, sir.
second ray is going without bending, huh? It is
Hmm.
going through the optical center. And third ray is just opposite of the first ray.
Means it is like the second ray is reflecting the first and the third one.
Yeah, you see, it's going through the focal point here, left side, then right side is going parallel. Our first ray
Maybe.
was left side parallel and right side was going through the focal point. Is it clear?
Yes, sir.
Okay, now our image we got here, that is inverted. Inverted means vertically inverted, right? It's vertically inverted. It is real. Real means it can be produced or it can be shown on the screen. That's why it is called real. And diminished means it's smaller than the object. Is it clear?
Yes, sir.
Yes.
Diminished.
Uh,
Okay, now camera or eye is done. Now projector. How we are getting the image in projector? When we are showing the image in projector, that time the position of the object is between F and 2F. And for this position, with the same rule we are applying. Our first ray parallel to the principal axis is going through the focal point. The second ray is going to the optical center, going unbending. The third ray going through the focal point, left side, right side is going parallel to principal axis. So they are meeting here and we are getting the image here upside down, inverted, right? Again. Hello?
Yes, sir.
We are getting the image inverted, then we are getting the image larger than the object. We say it's magnified. What we say?
Magnified.
Magnified. Karim,
yes, sir.
we get it magnified and we get this is real. Again, it is real. We can show it on the
Sir,
screen, projector.
sir, can we anyhow measure that? What is the magnification without just measuring the object and then the image? Is there any way to measure it?
What?
The mag. Okay, sir.
Yeah, yeah. There
The
is, there is. We will go for that. That is magnification. How much will be magnified? That one.
yes, sir. But
That one.
without
There is
measuring
formula.
the object
There,
and the image,
yeah,
and then divide it.
there is formula like image height by object height or image distance by object distance. You can get ratio that is giving you magnification. Okay, is it clear?
No, sir.
Like the image height we have and object height we have. If you take the ratio, we'll get magnification. Okay.
Sir, like we just have the values like their refractive index or the focal point, like those. But we don't have the height of the image or the distance they have in between. Like, is there any way just by looking at it and saying, my looking at the information they have provided with us?
Okay. In
Is
our
it
next meeting, we'll discuss that. Okay. You join after 6 to 7 minutes. I will tell you how to join. Okay.
determines on 50?